Kia ora, Year 10, 11 and 12. This is a request from Freeman for a stats question that's not from the Cambridge exam board. So it's actually from an EdExcel paper, and it's a really lovely probability question. So even though it's not from an old Cambridge paper, it could easily come up in our exam board, and it's a nice question. So I'm going to go through it pretty slowly. So it's all about socks. So Anju has got a bag of socks, and it's got 5 socks in it, and there are 2 blue socks. I'm going to read through the problem first, and then I want us to have a think about the best way to do this question quite slowly. So Anju randomly selects socks from the bag, 1 sock at a time, and she doesn't put any of them back, but she keeps picking socks out of the bag until she has got both blue socks. And remember, there are 2 blue socks and 5 socks altogether. The discrete random variable S is the total number of socks that Anju has selected. So I don't think that's worded that well. What that means is the total number of socks that she has selected to get both blue socks, right? So at the end of the situation, how many socks has she pulled out in order to get the 2 blue socks? So then I look at this next bunch of stuff, and I have to decide, what am I going to use to represent the probability setup? I have to figure out the value of the probability that S equals 1, which means that she ends up with 1 sock. Right? And then I have to find the probability that S is greater than 2, equal to 3. Then there's a conditional probability question. Given that the second sock is blue, find the probability that she has chosen exactly 3 socks. And lastly, that it takes her 5 goes to get the 2 blue socks. So when I look at this, I think about a table, and I think about a Venn diagram, and then I think about a tree. And in this case, a tree diagram is really, really going to help me. Some of you will be able to do this question without using anything, just by thinking about the situations with socks and probabilities. But for most people, I think a tree is going to help us quite a lot. So if you do find this easy, feel free to skip through to the end. But for most people in 12 MCA and 13 MCA, I'd recommend that we do a tree diagram. And I'm going to do that whole tree before I do this question. Except for this first one, write down the value of the probability that she gets 1 sock. Well, clearly she wants to end up with 2 socks, so the probability of getting 1 sock is simply 0, which is probably why it's worth only 1 mark. Then we have to figure out the probability that she takes more than 2 goes to get the socks. So we can think about that as 1 minus the probability that she takes 2 goes or less. Next, we're going to find the probability that she takes 3 goes. And then we're going to do this one. And finally, how often, or what's the probability that she needs to pull out all 5 socks before she gets blue socks. And the trick with this question is to think about replacement and non-replacement. So she's not putting the socks back in. So here we've got blue and not blue. This is sock 1. So the probabilities here look like this. And guys, apologies if I'm going too slowly for you. If I am, just put it on like double speed. Right, so there are 2 socks to start with that are blue and 3 that are not blue. Sock 2. Now this tree's going to get a wee bit messy. Well, if she's lucky, she'll pull out the second blue sock on go 2. Now there's only 1 blue sock left in there now, so it's 1 out of 4. And there are 3 not blue socks. The second time round, if the first one was not a blue sock, there are still 2 blue socks in there. So it's 2 out of 4 and 2 out of 4. Now at this stage, there's one way that she could have stopped after 2 blue socks, and it's here. So S equals 2. If she did blue then not blue, then on the next go, she might get her blue sock. And there's going to be a 1 in 3 probability of that happening. Or, sadly, she might not. Down here, if she's pulled out two not blue socks, things are looking pretty good for the next one being blue, right? So it's going to be 2/3 here and 1/3 here. But she has got no stopping point in any of those cases. And here, if she had not and then not, again, it's going to be 2/3 here. Hang on, I've done something wrong with this tree, haven't I? Yeah, this is wrong up here. Okay, let me just back up. I'm sure someone will have been yelling at me down their computer before this point. Right, let's just go a little bit more slowly. Okay, so here, this should be blue here. So the second one, she's got not and then blue. So she's got 1 blue sock left in there, so it's 1/3. And now she has got stopped in 3 goes. Right, and here she's got not, blue, and then not. So we haven't finished there. And here, if it's not and then not, it could be blue or not blue. So if it's 2 knots first, there are 2 blue socks left in there, and there's 1 not blue sock here. There's no stopping point coming up just yet. Let's see, but up here she's got blue, not blue, blue. So this one we stop now. We're at S equals 3. Right, so let's move on to this pathway. We've got blue, not blue, not blue. What can happen next? Well, she's got 2 socks left. And there's 1 of each left, 1 blue and 1 not blue. So here we've stopped at S equals 4. If she got blue, not blue, not blue, not blue, then she has to get the sock, the blue sock on the next go. So that probability is just 1. Right, moving on to this one here, we've got not blue, blue, not blue. Blue here with a 50-50 probability, 1/2 there, 1/2 here. So here we've stopped at S equals 4. And here we've got not blue, so we must be going to get the blue sock on go number 5. Right, now down here, what's left? Well, we've got not blue, not blue, blue. So there's 1 blue sock left again, so it's a 1/2 blue. So S is 4 here, 1/2 not blue, so S is 5 here. Right, so we go on to here, and we get S equals 5. Right, and here, if we got not blue, not blue, not blue, then we have to get the next 2 are going to be blue. So S is equal to 5. Now, another nice question here that we could do is we could say draw up the probability distribution table for this variable and find the mean. Right, but I'm not going to do that. I'm just going to stick to the question. But it's pretty easy now to figure out all of the answers to all of these questions. So let's just go back up to the questions. Well, the probability of having S greater than 2 is 1 minus the probability of getting the sock in less than or equal to 2 goes. So probability that S is greater than 2 is equal to 1 minus the probability of the number of socks she ends up with being 2 or lower. And we know that she can't get it in 0 goes or 1 go. So it has to be 1 minus 2/5 times 1/4, which gives me 1 minus 2/20, which is 9/10. And the next question is what's the probability that she took 3 goes to get the 2 socks? Now, you can do it off the tree, or you can think about it with scenarios, right? So blue, not blue, and then blue would have worked. And not blue, blue, blue would have worked. And if you can do this in your head without the tree, then that's just great. But a lot of you probably will go wrong doing it that way when you first start doing these. So reading this off the tree, the blue, not blue, blue one was this one here. So it's those probabilities there that I want. I'm just going to get rid of all of the markings on here to make it a bit better. Okay, so blue, not blue, blue there, and then this one here is going to be not blue, blue, blue. So moving back down to here, you can see that we've got, you can do this with your tree. So 2/3 times 3/4 times 1/3 plus 3/5 times 2/4 times 1/3, which gives me 6 over 60 times 2, right? Because I've got the same numbers in here and the same numbers in here, which is not an accident, right? But that's how it works out. So we get 1/5 for that one. Now, the next one is a conditional probability question, which I think is probably something you guys need a bit more practice on if you are like all other AS students. Given that the second sock selected is blue, find the probability that she selects exactly 3 socks. So in general, conditional probability is this. The probability of A given B is equal to the probability of both those things happening divided by the probability that B happens. So here we want the probability that given that the second sock is blue, what are the chances that it takes her 3 socks? So in the denominator, we just want the probability that the second sock is blue. And in the numerator, we want the probability that the second is blue and that she takes 3 goes. So going back up to here, this is the case that we want, right? So this is the probability that S is equal to 3, but only one of those has the second sock being blue. So it's those probabilities there. Oops. So it's 3 times 2 times 1 over 5 times 4 times 3. And the probability that the second sock is blue, tracing it out from my tree, comes from where? Probably that the second sock is blue. Well, I can get the second sock being blue this way, and I can get the second sock being blue this way. So that's 3/5 times 2/4. So what does all of that give me? Well, I get 6 over 60 divided by 2/20 plus 6/20. This is probably the trickiest of these questions. So I could simplify now, but I'm just going to do it the slow way. So it's 6/60 times 20 over 8, right? So dividing by 8/20 is the same as multiplying by that fraction. Simplifying this gives me 1 here and 3 here and 3 here and 4 here, which gives me a probability of 1/4. Right, the last question is asking the probability that it's going to take 5 goes to get the socks. Now you can see off the tree diagram, I'm just going to get rid of some of the bits on here so that we can more easily see where we're looking. What we need to do is just add up those scenarios where we've got S equals 5. Whoops, we did not want to do that. Let's try that again. So it's this one here where we're taking 5 goes. That one's taking 5 goes. This one here is going to take 5 goes. Now, you can't use a highlighter in the exam, but hopefully by practicing questions like this now, you'll see some fast ways to do this. So we've got 4 pathways for that to happen, but we can think about them again as cases. So we can either just get on with it and find those pathways. And if we do that, this is what we're going to get. We're going to get 2/5 times 3/4 times 2/3 times 1/2 times 1. The second one is where I don't get blue on the first go. So this is just using a well-constructed tree diagram, but there is a more intuitive way to do it, and I'll show you in a minute. And then the last way, guys, apologies if you're hearing snoring noises. It is not a human, it's our dog. So we've got to add all of those up. But before we start going crazy with our fractions, notice that the denominators are all the same in each case. So it's out of 120 without simplifying. And in the numerator, we've got a 2, a 3, a 2. Here we've got a 2, a 3, a 2, a 2. Because we've got a times 1 at the end. We've got a 3, a 2, a 2, and a 3, and a 2, and a 2. So we've got 4 lots of 3 times 2 times 2. And I can't believe I'm not simplifying faster, but let's whoosh 4 out of here and here. So that gives me 30. So 12 out of 30, which is 2/5. But don't stop watching the video. I want to show you the kind of smart way to do it. If you think about how it's going to happen that we get 5 socks needed to get the blue ones, it's going to be blue first, and then not, and then a blue, plus not blue, and then blue. So the place of that first blue sock is the only thing that's changing, right? Because otherwise we wouldn't be taking 5 goes. And then lastly, N, 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 B, B. And if you think about it like that, it's quite quick to work out those probabilities up there. So I guess what I'm saying is use a tree when you start doing problems like this, but some of you in the class already probably won't need the tree. But a tree is a really good technique to rely on if you are kind of a little bit stressed out in the exam, or if you haven't kind of seen the patterns going on with the lack of replacement here, because that's what makes this question hard, right? Is that she doesn't put the socks back in the bag. And so we've got 2 things changing at each step. We've got the numbers here are different depending on what happened out here. Okay, time is up. Freeman, thanks for sending in a fantastic question. Keep on asking for requests.